Hello everyone, welcome back to my channel. I am Jitesh Povankar, and in today's episode we will build an agent that will resolve latency issue. So in this project we will build an AI-powered SRE agent that will detect high latency using Prometheus. We will use Llama 3 with the help of Ollama for taking decision. It will automatically scale the Kubernetes deployment, and we will show the impact on the Grafana dashboard. So let's understand the problem statement. So in real world, not all the time we will get the CPU spike or memory spike because of the latency, but user start experience latency. And traditionally, our Kubernetes will scale the pods based on the CPU or memory, but in this case, it will not resolve this issue using HPA. To solve this issue, we will build an agent that will monitor the latency, that is user experience, make intelligent scaling decision, and automatically heals performance issue. This is the architecture we are building. So we have application that is latency app deployed in the Kubernetes. Then we have user traffic. We are monitoring using with the help of Prometheus and Grafana, and we have AI agent pod that will call the Kubernetes API and take the appropriate action, and we are using Llama with the help of Ollama. This is the workflow. So user traffic increases, then our application start showing the latencies. Prometheus collect the metrics and AI agent query the Prometheus. We will send this latency to the Llama 3, and our LLM take the decision based on the latency to scale the deployment or do nothing. Agent scale the deployment, latency reduces, and Grafana show the improvement. This is the tech stack we are using. So we have Kubernetes Minikube for container orchestration. We have Prometheus for metric collection, then Grafana for visualization. As usual, we are using Python to create the AI agent. Then Ollama to run the local LLM runtime, and we are using Llama 3 model to take a decision. And we are deploying this Kube Prometheus stack for monitoring. For this setup, we have to start your Minikube cluster with the Minikube start command. Then you can add the Helm repo to your Kubernetes cluster with this command. Then update the repos, and you can use Helm install and this monitoring and Prometheus stack. Also, you can create the namespace. I already created the namespace, so we can skip this. I will skip this command. You can create your namespace using this command. Then we will deploy this app and then create a service and monitoring. But before that, let's understand our agent. Now let's understand our agent. So if you come here, so we have this controller, and when we start our agent, it will print latency AI agent started. Then after that, we will get the latency with the help of Prometheus. Here you can see the Prometheus query. So this is histogram quantile, that is 0.95, that is P95U, and we are sending this query to the Prometheus, and Prometheus will get us the result. We will then send this result to our LLM that we are running on Ollama. So here if you see, we are sending this latency to the LLM, and we have specified this prompt here. You are a Kubernetes SRE agent, and we have specified if latency is more than 0.5 seconds, then scale the deployment. If latency is normal, they do nothing. So if the latency is below 0.5, then it will not do anything, and it will print to nothing. and this is the we are calling Ollama here. So this is our Ollama we are sending here, and we are specifying our model and prompt. So we are using, if you in the configuration you can see we are using Llama 3 as our model, and this is Prometheus. You are using local URL. The namespace your prod namespace, and our deployment name is Latency app. Also, we have specified the threshold here, that is 0.5 seconds, and check interval is in every 15 seconds. Our agent check the status of the pods, and then this is the max and max replicas as a guardrail. So we are specifying that you are only allowed to increase the replicas maximum 6. We don't want to scale in infinite, and also the scale replica is 4. So it will scale the 4 replicas, but loads keep we keep getting more load to the application, then it will scale max to the 6 containers. After that it will not allow to scale the application. And if you come back to the agent, then if you see the if agent is taking decision, if LLM take a decision to scale the deployment, then it will scale the deployment, otherwise do nothing. And if you come here, this is the Kubernetes client. So we are using Kubernetes Python library to connect with our Kubernetes cluster, and then this is our Prometheus client. Here we are sending our Prometheus URL and querying this Prometheus. And if you see, this is our YAML files. So this is our deployment object. And if you see here, like we are using this latency app as a label, and then this is our service object, and this is our service monitor. This is important because without this service monitoring object, we will not be able to get the metrics to the Prometheus. And this is our LLM brain, as I already discussed. So now let's start with the demo. So first we will clone this repo, git clone. Now we have cloned this repo, clear this, and this is the directory. Let's get in the directory. Okay, so now we have our files here. Now let's follow the guide. Hope you have started your Minikube cluster, and I already started, so I will skip this. And after I also installed Prometheus Grafana, so I will skip this step as well. Now let's create the namespace. So namespace is created. Now let's deploy our application. Application is deployed. Then we will create the service. So we have service also deployed. Then we will deploy our service monitor. Okay. Now let's check. So kubectl get pods -n prod. So now we have application is deployed. Also let's check our service. Yes, we see. Yes, service also running. Okay. Now let's start our agent now. So before that we need to create the environment. Now let's go to the green file. Let's create environment. Environment is created. Then let's activate the environment. Environment is activated. Now let's install the dependencies. Dependency installed it. Let's clear the screen, and now we will start our agent. Okay, our agent is started. So now we don't have any latency because we are not putting any load. So if we come to our Grafana, so here we must see, like if you see here, let's from started here. So our latency is 0.04 and our number of pods is running 2. So our pod is started. Two pods are running, and this is the latency we are seeing here. P95 latency. Now let's put the load. And if you see here, right? So our now latency is below 0.5, and because of that, our LLM taking decision to not scaling the replicas, and it is like pretty like do nothing. Okay, that means our agent is working fine and it is taking right decision. So now let's put some load. For this again, go to our renew file. If you come here, you can see like normal state we have pod 2 and latency is around 0.02 or 0.04. Now let's run the load. This is the file. This is the container from where we will put the load. This is the inside the container. Let's run some load. So now we will put some load, and okay, you can see here now it is from here now. So it will now increase. So you see here we are still latency is 0.04. Now we are putting the load. So now we are expecting the latency is on the application, and after the latency here our agent should increase the number of replicas. Okay, so here you go. So now the latency is increased. Now if you see here, here also it is checking. In every 15 seconds it will check, so it is waiting for 15 seconds, and after that once it got the latency, then it will increase the number of pods. So still it is not checking, not yet got this, so still waiting. It will take time to get the Prometheus metric. We will wait few minutes more. If you see here, like your latency is increasing, so wait. We are keep putting the load. Now you are go. So now it detect the latency 2.4, and now it is more than 0.5. So it is, or agent take the decision to scale the deployment. So if you come here, we will be able to see. Here you go. So our pods is scaled from 2 to 4 now. Okay. So now let's stop the load. It is already take the decision to scale the replica. So now we will stop the load. So here you go. So after some time, it will drop the latency because we will stop the load. And if we keep putting the load, then it will try to increase the more replicas. So if you see how our agent is behaving, it is continuously monitoring the status of the pods. If there is any latency on the application, and CPU is normal, so it will not scale the application based on CPU. So we need this type of agent that will scale the application based on the latency. So this is how. So now you can see still it is checking, and so if you find this useful, star this repo, subscribe to my YouTube channel, and share your feedback. Thank you so much.